Good afternoon. Today we're going to talk about life cycle analysis as it applies to any form of energy. And before we get started, I want to rehash this issue of why are we doing this Lcea. And so I like to divide it into two different pathways. One pathway would be I want to do, let's say, an Lcea on ethanol versus an Lcea on oil. And so this is a comparative Lcea. We're trying to find out which one has the most produces the most carbon dioxide, or which one produces the most inefficiencies in terms of energy consumption versus energy production. But it's a comparison. I'm comparing one to the other, and I'm going to set it up that way conceptually. The other one is simply to figure out on a conceptual basis, where are all the leakages? What are my bounds, and how do I constrain that problem? So if you start then and you say, okay, I want to look at which phase. Do I want to look at cradle to gate, cradle to grave, or cradle to cradle? And so with energy production, you could start and say, let's say we're going to do coal. All right, so how much energy does it take to mine the coal? How much energy does it take to move the coal? How much energy does it take all the way through the process? And what energy do I get out of it? That would simply be, all we're looking at is energy. No, nothing else. We're not looking at any of the leakages in terms of when I'm mining and I have runoff from the water, what is that doing to the environment, or what is that doing to the air pollution through dust, downstream problems with acid rain, etc. All the way through the process, we're not looking at that. Now you could look at that, and you could compare both those. So again, you need to set the boundaries on what it is you're going to look at. Set the objective for, why am I doing the analysis? Am I doing it as a comparative, or am I doing it just to determine where the most leakages are and where should I bear technology? One of the things that a lot of scientists, a lot of engineering people want to do is to try to identify those points in the process, in the Lcea that I've identified, whether it's cradle to gate or cradle to grave, is what are the leakages, where are the most leakages occurring. So that's the point where I want to practice putting most of the new technology so that I can make the process more efficient by reducing those leakages. So again, it comes back to all these things we've been talking about. Identify which phase you're talking about, identify those boundaries, and identify the objective. Am I going to do a comparative, or am I going to do a standalone to look at the leakages? So with that, you're going to be asked to do one with energy. You have a lot of freedom there. You can do any one of the ones that you like, and you can do it at any stage you want. You can do it from cradle to cradle. You can do it from cradle to grave or cradle to gate. That's up for you to decide. You could do a comparison between ethanol from corn or ethanol from cellulosic fibers. You can also do one of the wind energy versus electric generation from coal, or electric generation from natural gas. So all of those are available, and you can include environmental impacts. You can include the impacts on carbon emissions. You can include the impact on water quality and water quantity. You can include the impacts on air quality and air quantity, downward drift. All those things you can include. But that's part of deciding what the boundaries are on my analysis and how am I going to compare these two. It's not important what that boundary looks like, but it is important that everybody knows what your boundaries are, what assumptions you made, and what did you leave out of the analysis. So I'll let you get started, and we'll see how you get through that over the next week.